Free will, evolution and consciousness. This is an attempt to explain what free will is, how it is formed, and why it is neither predetermined nor random. Work and evolution-like processes may be very important in forming free will and, perhaps, even consciousness. We are engaged in work all the time, both consciously and subconsciously, consuming energy in the process. The importance of work could not be overestimated. Free will and consciousness may just be a product of our mental work while performing certain algorithms, not too dissimilar in nature from evolutionary algorithms. Animals do it too. Even plants do it. A plucked flower never regrows exactly the same, yet it also will not regrow just randomly. There is no fundamental reason why properly organized AI machines could not do the same. Artificial intelligence can and soon most probably will have both consciousness and free will. The necessary setup can turn out to be easier and simpler than we think. Someday computers will expand our consciousness, and perhaps merge that with the consciousness of machines, but only after we develop a decent computer-to-brain interface. Until then, we can directly feel, enjoy and attest only our own consciousness. Work. Every living thing is all the time working. It consumes low-entropy energy and is working against the elements and adversaries. It constantly looks for food, looks for low-entropy energy supply, and builds its own living cells, organs, environment, and societies. The work living things perform is the opposite in results from decaying processes, when they are dead. The importance of work is sometimes overlooked. Especially in our thinking process. We are very interested in whatever we are doing. We constantly think about what we are doing right now. We feel about what we are working on. Anything that we are working on enters our consciousness and enhances it. Even ideas we are working on enter our conscious mind and expand it. Perhaps ideas we are working on are all there is, they form the basis of our consciousness. And we are working on some ideas almost all the time, except when we are not, like in sleep or under sedation. But then, we are said to be either unconscious or with only some limited consciousness. Every living creature performs some work to survive. Every living creature works to resist the environment and to look for food. Every living creature could be conscious to the extent of problems they are working on. Every living creature possesses free will, to the extent they have to make decisions between several alternatives. The exact mechanism is, perhaps, evolutionary in nature and will be discussed later. Complexity is a key to quality. The most intelligent part of our brain is called the neocortex. It is the outer layer of our brain, responsible for most of our high-level thinking and intelligence. All mammals have a neocortex. It is made of 6 layers and is very uniform in structure even across mammalian species. All the regions of the neocortex seem to be primed with the same basic algorithm, at least initially. Cows' neocortex and human neocortex are very similar in structure, and, most probably, in underlying basic algorithms. The major difference is simply in size. The human neocortex is larger, and that could be the main reason we are slightly more intelligent than cows. But every living creature could be conscious, to the extent of their capacities. They are aware of their surroundings and they are aware of problems they are facing. Even a living plant is aware of its surroundings and is constantly solving growth and survival problems of its own. If you do not believe me, just watch a time-lapse movie of a growing plant. The most important word for life, awareness, consciousness, intelligence, and free will is work. Evolution, the mechanism. Evolution is everywhere. It is in nature, in human society, in computer science. It is a powerful idea and a powerful algorithm. In nature, evolution has produced all the complex life forms we see around. Evolution has produced us. In society, evolution has produced cultures, ideas, social structures, legal frameworks, and laws. That was achieved through trial and error, through building on previous achievements, through testing of various ideas, through inheritance and mutation, as any decent evolutionary process should. In computer science, evolutionary algorithms are very powerful computational tools. And they always work. What is evolution? For evolution to happen, we only need 3 basic components. 1. Variation. That is, some changes in existing structures. 2. Filter, which selects between different results of step 1, according to our preferences. The set of criteria for the filtering is called the target function. For example, in the evolution of life, the target function is simply survival. 3. Inheritance. The best results have to be saved and passed on to the next generations, so that they can build on previous achievements, repeating the cycle from step 1. I think that evolution-like processes are responsible for the development of our ideas and decisions as well. Let us consider our thinking process for a moment. Multiple ideas spring up in our minds almost all the time, including silly and even dangerous ones. Some ideas even come up as a mistake, or as a random fluctuation. We evaluate those ideas and discard the bad and dangerous ones while keeping the good ones. Then we might test some ideas and remember most of the good ones. Afterward, we mutate or recombine, mix, our ideas in pursuit of even better ones. This is an evolutionary process. And, yes, evolution-like processes can run within a single individual, very much like evolutionary algorithms can run within a single computer. Those are multiple ideas, which are being evolved in the landscape of our minds. The existing and brand new ideas are mutated and recombined in novel ways, then run through our internal models of the world for evaluation purposes. Then they are filtered according to our needs and preferences, implemented, and remembered. This is great and necessary work we are performing. And we are doing it all the time. We are constantly evolving new ideas and developing new ways of doing things. Sometimes new ideas on how to do things come after we have done something by mistake and then observed that it works surprisingly fine. This work of ours will generally turn out to be very successful, but we will never know in advance what the results will be. And the result may each time be different, even under exactly the same initial conditions. To better understand how exactly the same initial circumstances could lead to vastly different results, let us analyze evolution. Suppose you return to a certain, previous step in any evolutionary process, real or simulated, and attempt to repeat the process. Any, even the slightest random fluctuation could lead to a different branching of the same process. The smallest random, perhaps quantum, fluctuation would ensure that the future may be different in each particular case. And fluctuations, mutations, copying errors are essential parts of any evolution. So, while repeating the same evolutionary process, even under exactly the same initial conditions, we would probably get different results each time. Those results will, however, always be compatible with the real or simulated environment and the evolutionary target function used, in case of life, survival. The result of evolution will never be random, despite the random fluctuations within the process, and the results will always bear the signature of the world around, environment, and the evolutionary target function. In other words, if you have an ocean, and the target function is survival, you can expect to develop some kind of surviving fish. But you will never know in advance what kind of fish you will develop each time, even under exactly the same initial conditions. Random mutations alone will ensure that. And random mutations are quite necessary part of any evolution. They feed the evolution, but the outcome is always very far from random. Why? Because all the initially random mutations are put through the evolutionary filter, for example, utility and survivability filter. Thus the final result of any evolution looks quite intelligent, is beneficial, and is finely tuned for the immediate surroundings, the environment of this evolutionary process. There are a few things that could be said about any evolutionary process. 1. Evolution is incalculable and the number of possible outcomes is uncountable. That is, we will never be able to calculate all the possible outcomes of an evolutionary process, or determine potentially the best one. Why? Because under every single branching of the evolution tree, when evolution advances into one direction, but not the other, it opens infinite and uncountable new opportunities but cuts off infinite and uncountable other opportunities, which could have been available under the other branch. And this happens under every single branching event during the long process of evolution. 2. Evolution will never repeat itself. Even if we run just the limited evolutionary algorithm on our limited desktop computer, we will generally not get the same results every time. Even a single random mutation could ensure that. And random mutations are a necessary part of every evolutionary process. If not present naturally, they must be introduced artificially, as in any decent computer simulation of evolution. 3. It can be argued that any evolutionary process possesses free will. Why? Because it makes constructive choices. Generally speaking, the results are never expected to repeat themselves, even under exactly the same initial conditions. There will always be a choice, or rather multiple choices, in the process. However, the results will always be consistent with the environment and with the target function, so the results will never be just random. We will never evolve fish if there is no water in our environment. The results will look intelligent. And they will represent the environment, the evolving structure, and the target function. So, we will have a previously not determinable outcome, which will, nevertheless, be quite sophisticated and intelligent, and will bear the trademarks of the environment and the target function used. And, remember, multiple choices have been made throughout the process. Thus, it is very natural to perceive the outcome as the manifestation of free will, exercised by the evolutionary process in that particular run and in that environment. Or by the individual, using evolutionary processes within itself, to evolve different ideas, sort through them and take decisions. Free will. Even a few years ago, any discussion about the free will used to go into one of the two major and rather primitive dead ends. 1. If we regard the human brain as a deterministic system, subject to laws of nature, then under exactly the same initial conditions we must always take exactly the same decisions. Thus we have no free will at all, and we cannot be responsible for our actions. Free will, thus, must be just an illusion. 2. Yes, we know, there are quantum laws, which introduce fundamental randomness into the process, but then the decisions we take must be just random, and that is not free will either. I hope, during the last years, the science has gone past those two trivial and mistaken dead ends, but I am not quite sure. Let us take down both of them. First, even under classical physics and completely deterministic laws of nature, there is a well-known many-body problem. That is, you can easily compute, say, planetary orbits of two planets, but the job turns increasingly complex with the addition of more and more bodies. The butterfly effect is another way of saying it. The many-body problem quickly degenerates into outright unsolvable if the number of components becomes really large. Thus, it will be quite impossible to calculate even a finite and deterministic universe, except if we have a computer bigger than this universe, and the calculations are performed from outside. The smallest computer capable of calculating the universe is said to be the universe itself. Of course, a truly limited, isolated, and deterministic system, without even a single random fluctuation, would be able to repeat itself, but such systems rarely exist in nature. Yes, we can create a very limited and primitive universe in our computer, that could be deterministic and capable of repeating itself, but all determinism could vanish even if we introduce a single truly random fluctuation. Then, the real universe is not deterministic, it is quantum. It will surely not repeat itself twice. Fundamental randomness is embedded in nature itself. We can easily make even a small desktop computer non-deterministic by simply pointing a camera to the sky, and making some decisions dependent on the configuration of clouds. Or we can use a true quantum random number generator, based on nuclear decay, for example. Second, saying that random quantum fluctuations within our thought process automatically mean random thoughts, and thus no free will, is quite mistaken either. That would be equivalent to saying that random mutations and errors in the gene copying process would necessarily derail evolution itself and produce just random junk as a result. That is not what happens, of course. Random mutations are quite necessary for evolution. They feed the evolution, but the outcome is always far from random. Free will can be regarded as a somewhat similar process. An evolution of our thoughts. Our ideas, thoughts and decisions can be seen as evolving within our brain. Within our thought process, random mutations and other modifications to already existing ideas are implemented, tested and filtered. Only the best are kept. Under a very primitive layout, the process can be seen as follows. Our brain continuously generates new ideas, including random ones. The ideas are being generated, either randomly, or via interaction with the external world, or by recombining already existing ideas in novel ways. Some of those ideas are to be considered as mere fluctuations. Some of them may come while watching surprising consequences of unintended or even random actions. The new ideas are being created all the time, big and small, good and bad, potentially beneficial and outright dangerous. Ideas are being created consciously and subconsciously, on many levels. In our evolutionary analogy, that would be somewhat similar to random mutations of existing ideas, or recombination of those ideas in new ways. The consequences of these ideas are then evaluated, according to our internal model of the world, our personal preferences and our values. The best ideas are selected and kept, according to our needs and preferences. Bad ideas are discarded. In our evolutionary analogy, this would be similar to evolutionary filtering according to some target function. Based on our best ideas, decisions are taken, actions performed and consequences observed. Best ideas are then remembered, ensuring inheritance. Our internal models and our preferences are updated. We are learning. Our moral guidelines and preferences are modified, as per our experience. Thus, forming and exercising our free will is constant and never-ending work, quite similar to an evolutionary process. All our ideas are run through our internal model of the world, and our value system, to estimate and forecast what the consequences will be. The ideas we select and approve, even if initially random, bear the signature of our personalities. We are, thus, responsible for them. Those are our ideas, our decisions. Even under the same initial conditions, we could easily come up with different decisions every time, but those decisions will always be filtered through our personality and our value system. Thus, those will be our deliberately worked-through decisions, they will be our unforced, free decisions, and they will be our decisions. They will bear the marks of our personality. We will always be responsible for them. These processes could happen in our brains on multiple levels, in parallel, consciously and subconsciously, and all the time without a stop. Like in any evolution, the process of exercising free will is not calculable. The set of all the possible variations is infinite and uncountable. We will never know in advance what decisions exactly we will take every time, even under equivalent initial conditions. But they will always be consistent with ourselves. In other words, a loving mother would seldom intentionally harm their child, a pacifist will rarely go to war. Every decision we take eliminates multiple and uncountable branches of other decisions we could have taken, and opens multiple and uncountable branches of new follow-up decisions that we could take. There is no room for any physical determinism there, even under classical physics rules, as the multiple particles involved and all the interactions with the external world render all determinism impossible. And there is always quantum randomness involved, so we will never be able to predict what decisions the brain will take each time, even under exactly the same initial conditions. But the final outcome will not be random, as it will be consistent with ourselves, with the task at hand and with the environment. In other words, we may spontaneously shake our heads, but we will rarely spontaneously jump out of windows. Our decisions will not be random. They will bear the signature of our personality, knowledge, circumstances, and our thinking processes. They will be processed through our internal filters, adjusted to our needs, circumstances, and values. All our decisions will be worked through our values and preferences, including moral and ethical ones. They will be our decisions. So our free will is neither predetermined nor random. It is a result of constant work by our personalities on many initial ideas, including random ones. Those initial ideas are being processed and evaluated by our brain, picking the most suitable ones. We are making decisions with all the power of our brains and personalities, using evolutionary processes while doing it. The decisions are not forced upon us, so they are free, and they are heavily processed within us, so they are ours. And they are not random. Even if sometimes we would decide to mentally toss the coin, the reasons and consequences of such a decision would have been first evaluated and approved by our thinking process. All our decisions are free, but they are also very personal. Even if circumstances were exactly the same, we could still come up with a different decision each time. And each time we would not think about our decision as unreasonable, at least not initially. Of course, we can sometimes be forced, cheated, manipulated, misinformed, hypnotized, or simply wrong, but that does not take away our ability to exercise free will in principle, at least under better conditions. And hopefully, we will learn and be better next time. Making free decisions is thus hard and necessary work, performed by us constantly and continuously. We are alive and consuming low-entropy energy while doing this important work. Our decisions are neither random nor predetermined. They represent us, and the constant evolution of ourselves and our decision-making process. Our free will ends only when we die, and some will dispute even that. Every living system has free will. Free will is associated with every living and evolving system if they are sufficiently complex and equipped with proper algorithms. I would argue that even plants do exercise some degree of free will and perhaps consciousness. The plant will never regrow exactly the same after being trimmed. The plant also perceives and investigates its external environment, even if in a very simple manner. It always looks for better paths while it grows. If the computer system is complex enough and equipped with proper basic algorithms, it can possess artificial intelligence and free will exactly for the same reasons. And it will most probably be conscious while working on its problems, even if in a very simple way. How will we know? We will not know, as we are directly aware only of our own consciousness, not even of that of our child. Similarly, a sufficiently complex computer will be conscious of itself, aware of itself and the surroundings, and could tell us that in no uncertain terms, but we will never be able to attest to the consciousness of a system we are not mentally connected to. However, we will soon start to take them seriously, for example, when they will put up a fight for their own rights in perhaps not too distant future. What complexity are we talking about? Well, there are about 25 billion neocortical neurons in the human brain. They make about 140 trillion neocortical connections, synapses, between them. That is, on average, about 5,600 connections per neuron. And each neuron, even though rather simple, is much closer to a complete microprocessor than to a mere transistor. So, when we will assemble about 25 billion laptops and connect them into a network with about 5,600 average connections per unit, we will probably be able to discuss free will and consciousness with that creature on equal terms. Provided, of course, proper basic algorithms are installed, or evolved, within, and a learning process, similar to that of human education, is properly carried through. It can be argued that societies are also capable of learning, evolving, freely deciding certain items, and being conscious. Of course, we will never directly feel and be able to attest to the consciousness of any other being, except ourselves. Or would we? Suppose we find some way of merging our brains and thinking processes. That is not impossible at all, at least in principle. Suppose we develop a good brain-to-brain or computer-to-brain interface. Will we be able to expand our consciousness then, and, perhaps, be able to merge with the consciousness of another subject computer or human? It could be possible, and perhaps even in the not-too-distant future. Some breathtaking opportunities await us then.